So now we'll be doing chapter 5, which is logarithms from Cambridge Additional Mathematics. Okay, so we'll start with logarithms in base 10. So we just have to first understand what a logarithm is. So let's say f of x equals 10 to the power of x. Now let's find the inverse of this function. So I'll just find it. Yeah. So let f of x equals 10 to the power of x. To find the inverse of this, we'll have to replace the value of x and y. We'll have to interchange them. So we'll do that. This was part of, I think, chapter 2, functions. So now you might be confused what to do over here because this we haven't learned it. So in order to find the value of y, we should apply logs. This is base 10, by the way, to both sides. This is what we do in order to make y the subject of the equation. So this is basically how you'll do it. And also log 10 to the power of y base 10 is equals y. So the inverse of 10 to the power of x is this one, log x base 10, which can also be written as lgx. These two are equivalent. If they write lg, it means you have to assume that it is log base 10. Okay, so now, so I'll just show you the graph. This is the graph of x to the power of, 10 to the power of x. So we know that the inverse is the reflection of the graph over the line y equals x. So therefore, this will be the inverse. And this is the graph of log x base 10. That's basically the meaning of log x or whatever you get in the future. Okay, so now we'll see how to solve problems. So the logarithm in base 10 of a positive number is the power that 10 must be raised to in order to obtain the number. So it's very simple. So we have already learned in exponents that maybe 1,000 could be written as 10 to the power of 3. We'll use the same concept here. So for instance, log 1,000 base 10, we can rewrite 1,000 as 10 to the power of 3, and then this would be simplified to 3. Similarly, we can write 0.01 as 10 to the power of minus 2, and if this number and the base are same, then the answer would be the value of what this number is raised to. It only works if these two are the same numbers. So hence, this is minus 2. And we can therefore derive the general rule that log 10 to the power of x equals x for any real values, and a equals 10 to the power of lga. So that's just something you'll have to remember. So yeah, so now let's solve these problems. Okay, so now let's start with this one. So what we could rewrite this is lg. First, let's rewrite this in the form of 10 because the base is 10 over here. So we'll have to find the cube root of 10 squared. So we already know that this could be written as 2 by 3. We learned this in exponents. So this, we know that the base, this is basically log base 10, 10 to the power of 2 divided by 3. So as we learned over here, in the general formula, this would be equal to 2 by 3. You could use your calculator to find it and you'll still get the same answer. Okay, so now let's solve this. Log 1 divided by this. We can rewrite this as implies that 1 divided by 10 to the power of 1 by 4. We know that 1 divided by a to the power of n equals a to the power of minus n. So therefore this would be 10 to the power of minus 4. 1 by minus 4, minus 1 by 4. Therefore the answer would be minus 1 by 4. Now let's solve this one. Okay, so what we can rewrite this? We could rewrite this as 10 to 10 squared. It's the same. And now we'll use the property of this to rewrite this. This implies that LG 10 to the power of, this would be a plus 2. So the answer would be a plus 2. So this is our final answer. Let's solve the last one. It is LG log base 10, I think it was 10 to the power of a. Yeah, 10 to the power of a divided by 10 to the power of b. So we know that we could rewrite this as 10 to the power of a minus b. It is the rule that we learned. This would be simple. This equals a minus b. This is our final answer. Okay, so now let's move on to the next one. So logarithms in base a. So it's very similar to logarithms in base 10, but here a is some unknown value. So if f of x equals a to the power of x, then f inverse of x equals log x base a. It's very simple. And now there's a similar rule that x equals log a to the power of x base a. This is very similar to the other one, and so is this. And provided that a is greater than 0. It must be greater than 0 because if the base is a negative number, you can't really solve it. Like, it's just a rule that the base must be greater than 0. It cannot also be 0. So now let's solve these equations. So we can write 4 as 2 squared. So since this value and the base are same, we could just rewrite this as 2. Now let's solve this one. Yeah, this may seem complicated, but I'll teach you something simple. 4 to the power of 1 by 2 equals x, because we'll use this snail rule, meaning the base would become the base of the exponent. Meaning if we move this here and make this the power, then we get the value of x. Implies x equals 4 to the power of 1 by 2. This equals 2. So now even if we plug this back into the equation and see, so we could write 4, 2. With this we could have written as 4 to the power of 1 by 2 because we have to make this value the base equal to the base. So therefore this would be equals 1 by 2. Now that we have verified it's correct. And now let's find this. 8 can be written as 2 to the power of 3. Therefore the answer would be 3. Pretty simple. So now let's solve this. 25 can be written as 5 squared and root 5 can be written as 1 by 2. So we could write log base 5 squared into 5 to the power of 1 by 2. And now we could add these 2 plus 1 by 2 because we know the property, this property. So this would be 2 plus 1 by 2, that is 2.5. So the answer would be 2.5. And now we could write root a as a to the power of 1 by 2, and we could use this property to rewrite this like this. So the answer would be minus 1 by 2. And now we'll use the snail rule over here. The base moves here. This base, the base of the logarithm, would be the base of the exponent. So we could write this as 81 equals x to the power of 4. And now what we could do is write this. This is 1 to the power of 4 equals x to the power of 4 into 1 divided by 4. So we'll have to find the value of this. So x, these two will cancel out, meaning that x to the power of 1 equals 3, because 81 to the power of 1 by 4 is 3. So therefore we got our answer.